Hello, in this video, I'm going to explain about the solution for question 4-4 and 4-3. First up is we would make an equation of displacement which is summation P times L divided by A times E. P would be the internal axial force, L would be original length of the rod, A would be the cross-sectional area of the rod, and E is the modulus of elasticity for the steel rod, A-36. And we would get this PL of AB divided by AE, PL of BC divided by AE, PL of CD divided by AE. And given in the question is the cross-sectional area of the rod, which is 50 millimeter square. Would have to divide it by 1000 square to get meter square, and this is to it would make us convenient to calculate our values later on. And E, which is the modulus of elasticity for the rod, A-36 is 200 GPa converted to Pascal, which is 200 times 10 to the power of 9. And the next step is we'd have to find the internal axial force for AB, BC, and CD. And for AB, we'd have to cut the part AB. We'd cut it in half, put an imaginary line, we'd get this diagram, and we make an arrow to the left to show the internal axial force for AB. Summation of force of X equals to 0. We come up with this equation and we solve for X. We get X equals to -3 kilonewton. And for BC, we would cut this part of BC in half. We'd get this diagram and an arrow to the left to show the internal axial force for BC. Summation of force of X equals to 0. We get this equation. Solve for X. We get X equals to 6 kilonewton for the internal axial force of BC. And for CD, we'd have to cut CD, put an imaginary line to cut it, and a force of internal axial of CD. We make an arrow to the left to show its direction, and summation of force of X equals to 0. We get this equation. Solve for X. We get X equals to 2 kilonewton. And after getting all the values of internal axial force for AB, BC, and CD, we sub it back inside this equation and we convert this value to Newton, and Newton for our calculation convenience, and we would get this value for the displacement of its ND, which is 8.5 times 10 to the power of -4 meter. Now we move on to question 4-4. And in this question, we were asked to find the displacement of C. Well, first up is summation of PL divided by AE. We would get this PL of AB divided by AE plus PL of BC divided by AE. As I've said, P stands for the internal axial force, L the original length of the rod, A cross-sectional area of the bar, and E modulus of elasticity for the rod. And given in the question, we have the cross-sectional area of the rod is 50 millimeter square. We would have to divide it by 1000 square to get meter square. This is for convenience in our calculation later on. And the modulus of elasticity for A-36 steel rod is 200 GPa, and converted to Pascal, we would get 200 times 10 to the power of 9 Pascal. And like in the previous question, the next step is we would have to find the internal axial force of AB and BC. And for AB, as we'll have to put an imaginary line here, and we take it, and we will get this diagram and an arrow to the left showing the internal axial force for AB, and summation of force of x equals to 0. We get this equation. Solve for x, we get negative 3 kilonewton for the internal axial force of AB. And for BC, we'd have to make an imaginary cut here, and we would get this diagram and an arrow to the left showing the internal axial force of BC, and summation of force of x equals to 0. We would get this equation, and solve for x, we get x equals to 6 kilonewton. And after getting these values, we would have to sub this inside the equation earlier on and get your calculator, type these values, and we would get the displacement of C is equals to 0.6 times 10 to the power of negative 3 meter.